find the values of cos times AB, for which the function, we have certain conditions, f of x is equal to this function when x is what? Less 1, f of x is equal to a minus 1, and x is equal to 1, and then f of x is equal to this quotient function when x is greater than 1 is continuous at s. The first thing we need to note is what is the condition for continuity. When is a function is going to be continuous? That's the next question we should be asking. That's when is a function is continuous? And the answer to that is straightforward. A function is continuous when the left-hand side of a limit is equal to what? The right-hand side of a limit. For the left-hand side, we have as x tends to a negative. Let's imagine that your a is 1. That means x tends to 1 negative. So what you need to do at that point is to look for that function where x is what? X is less 1. So here, the left-hand side is less what? Is less a. For the right-hand side limits, x tends to a positive. So we should be looking for function where a is more than, if this place is 1 plus now, it's going to be where the function is what? More than 1. And then if it's continuous, if limit exists, if this and this equal, then you're going to have limit of f of x equal to limit of f of x as x tends to what? As x tends to a. And that will be equal to what? F of what? F of a. Okay. So this is going to be the roadmap to this question. So the first thing we are going to look at, we can see all the values here are the same thing, 1, 1, 1. Okay. But for clarity, here x is more than 1. This point now, this is where you're going to have x tends to 1 plus. X is more than 1. So this function is going to give us the right-hand side of the limits. Here, x less 1. So we're going to have x tends to 1 minus. So that is the function. The function here is this. When x is what? When x is less than 1. So if limit exists, this limit of this place and this limit of this place must be exact. So let's look at that. The first one, limits of f of x as x tends to 1. I'm going to start on the right hand side, 1 plus, and where we have that, where we have x more than 1 is this function, and that will be equal to, substitute that function there. So, and we're going to have limits as x tends to 1 plus. This one will give us x minus 1, x plus 1, plus b into bracket x minus 1 all over what? X minus 1. So this one and this one we cancel out. Okay, I try to avoid zeros at the denominator, and that's why I did the algebra of this one. Okay, so this one and this one we cancel out. How did I know? I can factorize that. Let's factorize that. This one and this one is common. Take it out. X minus 1, take it out. So I have x plus 1. Okay, plus what? Plus b all over what? All over x minus 1. So you can see now it cancels out. Then after that, you can do your direct substitution. So 1 plus 1, anywhere you see your x, you put 1 there. So that'll be 1 plus 1, that's 2 plus what? Plus b. So that is the right hand side of the limit. Let's get the left hand side as x tends to 1 minus. The left hand side is what? Is this place. The function there is what? Is cos. So do your direct substitution. Anywhere you see your x, put 1. We have 1 there. Okay. Then we've been told another thing we can do also is to find the limits as x tends to 1. When x is equal to 1, the function is what? A minus 1. So we have a minus 1 So that's no, this is a constants, so just be a minus 1. We know this. So on the final note, you just have to make come back here. Come back here. The left hand side is equal to what? Because for continuity, the left hand side of the limit must equal to the right hand side, must be equal to this one, must equal to this one. Okay? The left hand side limit is what? Is 1, which is what we have here. We have 1, it's giving us 1. Okay? Equal to the right hand side of limit, we have what? 2 plus what? 2 plus b. Okay? And that's equal to what? That must be equal to limit of f of x as x tends to 1, which is f of 1. And f of 1 is what? That's what? That's a minus 1. Okay? I've done that. A minus 1. Okay? So we can solve this. We can solve this too. So b is equal to what? B is equal to, move this one to the other side. That's minus what? Minus 1 is equal to 2 plus b. At the same time, 1 is equal to what? A minus what? A minus 1. So if you solve this, a minus 1 is equal to what? Is equal to 1. So a is equal to what? A is equal to 2. Okay, so that's the value we have for that. A is 2, b is minus 1. So that's just that on the left hand side limit and the right hand side limits on continuity. The question has been stipulated that the function is what? It's continuous. And when it's continuous, we expect the left hand side limits, right hand side limits to be equal to each other. Limit exists at that point. Okay, so that's that on this particular question. Okay, if you're watching me for the first time, there's a watermarks on the video. Kindly smash it and hit the notification bell so that you get notified anytime I upload a new video. Click on the like button and begin to type your comment. Okay, finally, share the links on all your social media platforms. Thank you for doing that. The next question, evaluate the limits. We have a limit as t tends to 0 of this quotient function. As we all know, the first thing we do is to do the direct substitution. And if you do that, you're going to have e to the power 0 minus 1 minus 0 all over 0. Give you 0 over 0. And when you have 0 over 0 or infinity over infinity, we call it indeterminate. And that calls for L'Hopital rule. Okay, and that will be equal to as t tends to 0. Then you differentiate this, and that will give you this. The derivative of this one is 0, and this one is what? 1. All over what? Differentiate this one respect to t, all over 18 t. Apply, do your direct substitution again. You have what? 0 over 0. That's what? Indeterminate. Then apply L'Hopital rule. And that will also be what led to your 0 by 0. Differentiate that function. Differentiate this one. That's what? That's this. By what? Over 18. And if you substitute, that will give you 1 by 18. And that's the applications of that. On the playlist, I've dealt with a series of questions on L'Hopital rules. Endeavor to check the playlist and check more of the questions on several cases of indeterminates that led to the use of L'Hopital. Thank you for doing that. And finally, there's watermarks on the video. Quickly smash it now and hit the notification bell. Don't stop there. Click on the like button and begin to type your comment. Finally, share on all your social media platforms.